This video is provided for the technically minded to explain what's going on behind the scenes during a hot clone. First, we need to explain what's involved in a cold clone from a technical perspective. A cold clone is a relatively simple operation to understand. The source PDB must be in a quiescent state, hence the term cold clone. Basically, you close it and reopen it in read-only mode. In this state, there are no incomplete transactions and all blocks are flushed to disk. Performing a cold clone is therefore simply a matter of scanning all the blocks of the source and copying them to the destination. Even this is a sophisticated operation, however, as parallel slaves will automatically be invoked to optimize performance. Once the clone is complete, the source PDB can be reopened read-write for processing to resume. So we can do cold clones. Why not just do hot clones? It's easier said than done. I shall explain why. Before we get into that, let me illustrate what is going on in a database which is open read-write. Here we use color coding to show the passage of time, as illustrated by the clock in the upper left corner. So in the first time interval, we could think of this as purple time. We see some data changes in blocks scattered throughout the data files on disk. Corresponding to this, we have undo segments in the undo table space, and of course redo segments written to the redo log file. Each of these changes is color-coded according to its time interval, in this case purple. Notice that some of these changes, data file blocks, undo and redo, have check marks. These indicate that the change is associated with a committed transaction. Now, as we move into brown time, we see some more changes. Notice that one of these changes is to commit a transaction that began in purple time. All of this is summarized in the legend on the right of the slide. We can now watch the database activity proceed as we progress through pink, orange, and grey time. The point of all this is that in general, we must assume that this sort of activity is going on in a database which is open read-write. That is, transactions are changing data blocks scattered throughout the data files, and it is not reasonable to assume that at any time there are no uncommitted transactions. Hot cloning needs to take account of all of this activity. With all these changes going on, it is hard enough to guarantee that the clone be physically consistent with the source. However, what is required is that it be transactionally consistent with the source as well. Incidentally, this is why it's very important not to rely on storage-level replication technologies alone to clone your databases. If you do so, the operation will appear to complete successfully. However, there are likely to be some transactional inconsistencies. Now that we understand the challenges to be addressed by an online, that is a hot clone, let's see how it works. Again, we'll use color coding to illustrate the passage of time. We begin the online cloning operation in purple time. As with a cold clone, we do a parallel scan of the data files. In this illustration, during purple time, we scan the first two rows of blocks as shown. These are read and copied over to the target. So far, everything is okay. All changes made to blocks in the primary that we've scanned so far are copied over to the target. Now, as we run into brown time, we scan the next set of blocks. Again, there are some changes made in brown time that are picked up by this scan and copied over to the target. However, there are also some changes made to blocks which were previously scanned. These changes are therefore not reflected in the target. And now we can proceed through the pink, orange, and grey time intervals. As before, we see that some of the changes made in the primary during the cloning operation are reflected in the target. However, some changes made to the primary during the cloning operation happened after those blocks were scanned. Those changes are not yet reflected in the target. Here we see, with the red X's, the blocks in the target in which the corresponding block in the primary has been changed, but that change is not reflected in the target. So far then, we have copied all the blocks from the primary to the target. But because the primary was changing while the blocks were being scanned, what we might refer to as a fuzzy read, the target is not physically consistent with the primary. The next step is to fix that. This is done by copying over all the redo that has accumulated since the cloning operation began, scanning it, and applying all those changes on the target. The result of that is a physically consistent clone on the target. However, note that not all the transactions in this physically consistent clone are committed. It is now necessary to roll back any uncommitted transactions. This is done by applying the undo corresponding to those uncommitted transactions. When this is complete, the clone is in a transactionally consistent state. The relevance of all of this from a high availability perspective, of course, is that hot clones allow cloning operations to be performed whenever necessary without incurring an outage in the source system.